Evo, dobro jutro svima. Nadam se da vam nije možda malo toliko prerano jutro koliko je možda na primjer meni. Lijep pozdrav svima, ja sam Misla Major i eto tu smo danas na treku dvojici. Hvala što ste došli na BSides i sad ću se malo probati svičati na svoj broken English, pošto kao ipak nije jest da ovo BSides Zagreb, ali ovo je sad već lagano internacionalna konferencija. Imamo dosta speakera koji nam pričaju na engleskom i ako me ne razumijete, prebacit si na hrvatski, ako baš ono zaštekam. So, our first speaker comes from Argentina. This is Santiago Abastante, and he is a former police officer from Argentina. He is now cloud incident responder and security engineer, and he will talk about hiding malware in Docker images in AWS for hardcore persistence and defense evasion. So this is a pretty modern topic. I believe we are all interested in that. So, Santi, I will let you do the talk.
Great, thank you. Hi all, how are you doing? Well, as he said, I'm Santi, I'm from Argentina. This is my first time in Croatia, so I'm really glad to be here. Thank you for having me. And also I came here alone, so please talk to me. I really like going to community conferences because I want to know how different countries do cybersecurity. I find that it's not the same how we think cybersecurity, and I think sharing is like the best that we can find in cybersecurity communities. So yeah, I would be here all day. So if you're around, and please reach out. I would be more than glad to. The talk is called "Hiding Malware in Docker Images" for hardcore AWS persistence. The main idea. I'm an incident responder, and I see all day that from the offensive part of the security, we are like all well trained and know a lot of and really know what we do when we are doing a penetration test or red teaming exercises. But most attackers are not like like us, right? They maybe are well trained in some technology like AWS or Azure, but when they got to compromise an environment, they don't do the happy path and they move along with whatever they know or with whatever they can find. So the main idea of this talk was like to try to understand how like the internals of the AWS components work, so we can understand what the attackers can do besides that we can learn in an AWS training course. So the everything, well, this is me. I like traveling. I like hiking. I'm a digital nomad, so that's why I'm here. I'm staying in Europe for 3 months. This thing uh, came to me in Japan. I was in a incident response conference talking with a friend of mine that works in Virus Bulletin, in Virus Total. Have you heard about Virus Total? Well, he was talking to me about some Brazilian threat actor that used Delphi to code malware, and he was saying like, yeah, you know, they use Delphi because nobody knows how to decompile Delphi because it's like a really old programming language. So most modern researchers are most used to C and Go, but whenever they find a Delphi a piece of malware, they like struggle. And also the Brazilians used to like create big files to bypass antivirus because he told me like, okay, antivirus when they find like a really big file, they tend to skip them. And it was like, fuck, how is like the antivirus industry works like that? And it was like, what can we do from the cloud perspective, or what are the cloud industry doing if the antivirus industry that is like 20 years longer is doing those skips, right? So I started to think how does the virus and malware detection working in the cloud environments like Docker components and Lambda environments and AWS stuff, right? So what I did was to create an ACAR file. Have you heard about the ACAR file? Well, for those who haven't, the ACAR file is like a string of text designed for the antivirus to be tested, right? So this is something that every antivirus should detect. And I published that to VirusTotal and got that almost all engines were able to detect them. But then what I did was to zip the ACAR file and try to push that to VirusTotal to understand what was the difference, only by zipping the ACAR file. As you can see here, we have like 61 detections. If I go to VirusTotal, and I choose like this acar.zip, is the same file, but we already have like less detections that what we could have like with the normal file. So, and only by zipping it. So there are already some engines that are not detecting this. And I found that like super interesting because it's like, okay, if an antivirus does that, what happens with Docker, right? So I created a Docker file, plain Docker file, only with the ACAR text, and pushed that to a Docker registry. And I was able to push that without problem. I was able to upload that to Docker Hub. If you go to my Docker file, Docker Hub link, you would be able to download that. This means that every threat actor is able to push Docker files with malware to a Docker Hub, right? Without any restriction at all. And this is particularly dangerous because this is like a trusted source, right? So I started to think about how to connect everything together, especially related with trusted source, Docker images, the lack of knowledge from incident responders regarding all this set of tooling, because what I found in the real environments is like not every incident responder knows about cloud, and not all cloud engineers know about how to do incident response. So there is like a skill gap that attackers can like take advantage of. I also try to run some kind of scan. The scans designed by Docker registries and those kind of tooling is more related to vulnerability management. So they are ready to find like misconfigurations in the Docker file, but not they are not like looking for compromise or to malicious code within those uh, those tools. So it happens the same with ECR. So with all this like brainstorming, I was thinking about, okay, if an attacker got persistence or got access to my AWS account, what they could do. And I started to think how an attacker could like use all they know about AWS to exploit this knowledge to bypass most of the defenses, to understand if AWS was able to allow me to do that as an attacker and notify me as a defender, right? Because the main problem with AWS is the shared responsibility model, in my mind, as an incident responder. Because the shared responsibility model, what it does is like say, okay, this part of the stack, the technology stack, is yours, and this part is from AWS. So for example, if I'm using a EC2 instance that is a server, I, as an engineer, I cannot handle the internals of the server. I cannot handle the power grid. I cannot handle the internet. But I can harden the operative system. I can work with the networking. Besides, I don't have NetFlow. I don't have like packet inspection. I would have NetFlow, for example. But when I'm like moving to the SaaS part of the shared responsibility model, like a lambda function, there is less than a defender can do, and there is more in the AWS side of the responsibility model. And we cannot delegate responsibility. So if I trust AWS to do some security practices and they are not doing that, and I'm compromised because of that, besides this called shared responsibility model, I would still be accountable for that compromise, right? So when working with SaaS environments, the issue is that I can do less things. Which one? Only for me to get an idea. How many of you work with AWS, cloud, and that stuff? Okay, half of you. Well, are you following with me with the shared responsibility model thing? The idea with a lambda function is it allows me to execute code in the cloud. So the only thing I can handle is the code that is going to be run. So I don't have access to the operating system. I don't have access to the network components. I don't have access to anything of that. What I do have is a lot of security tooling from AWS to do threat detection, logging, monitoring, and that's what we need to bypass in order to execute code in these kind of environments. The thing with that is like those threat detection mechanisms are based on the logs that AWS have, and we can trick the cloud to see what we want to see. For example, we are going to go in detail further, but if I execute an API call, everything in the cloud is API based. So a lambda function, a server, the creation of a user are API calls and are going to get logged. No matter what, they are going to get logged. But it's not the same if I'm creating an IAM user from Zagreb and I'm working every day from Zagreb, that suddenly I'm executing an API call from Argentina, because that's weird. But if the API call comes from an AWS server, it's like more for the detection engine, is easier to bypass their behavior analysis and their machine learning algorithm that they have to create detection. So it's easier for them to associate with a false positive and bypass the detection. So we're going to trick the engine with those kind of things. For you that don't know, the most important component in AWS is what's called IAM, that's Identity and Access Management. That's the part of the cloud that allow me to execute API calls. Are my permissions. It's like the things that I can do as a user. In order to achieve that, to achieve what I'm going to do, I need sufficient permissions first. I can elevate privileges in different ways, like attaching policies or modifying policies, or there are different things that I can do. But the most important thing is for me to do what I'm going to do now, I need sufficient permission. So the most important thing that we can do as defenders is to harden that. It's not an easy thing because most of the time when we start doing things, we do that like in a secure way, but time to market used to drive like companies to do things like faster, and suddenly they soften the restrictions and suddenly they have permissions, users with administrative permissions. For example, infrastructure as code users, GitHub users, the things that are used to create infrastructure, the operation users that are used to deploy code. Those entities are used to have like a lot of privileged, and we can exploit them to move along and execute what we are going to execute now. As I told you, this is how a lambda function, how you can see a lambda function. For me, the most important feature for an attacker to understand is like we can deploy code. Like I'm going to show you the IDA right now, but we can create code using the IDA in the lambda function. And if I, as a defender, need to get that information, I'm going to see the malware and the malicious code. But I can also upload a Docker image to execute a Lambda function. So then I'm not going to be able to see the code. I would need to get the Docker image and then decompile the Docker image to understand what's going on. And most of the time, there is where I can like hide and encapsulate my malware to do what I want to do, and also to generate layers of complexity for the incident responder. Think that if you are an incident responder and you are getting this, you need to know already how the networking works, how AWS works, how Docker works, how to run different architectures of Docker images. For example, I can generate a Docker image with a different architecture that the normal operative system works. For example, if I know that you are using Windows, I can use ARM. And then you need to now know how to run an ARM Docker image in your Windows machine for you to analyze that. And those small steps of complexity give us time. The other thing that we need to understand is that there are Docker registries that are the AWS tool for replace the Docker official registry repos, right? The thing with this is like it's another trusted source that will bypass the security detection. Most of these tools, what they have is like they are associated with the normal software development lifecycle. So if I'm creating a Docker registry and I'm adding an image to a Docker registry and then I'm running a Lambda function from that registry, that's something that is normally associated with what a developer is going to do in a production environment. It's not that I'm creating a server out of the box. It's something that tends to be part of the normal behavior of an AWS account. That's why we create an AWS account. So these API calls are not strictly bad on their own. The thing is that connecting everything is when they get like to be dangerous for the tenant. The last thing that we need to complete what I'm going to do is the API gateway. The API gateway allows me to expose to the internet a Lambda function. See? The Lambda function would be presented to the internet using an URL that is provided by Amazon Web Service. So if I'm doing something against this API gateway, I'm going to be able to expose an API endpoint that is going to be logged with an Amazon Web Service domain. So if I'm working from inside a computer from a workstation of a DevOps, and I'm executing API calls against this endpoint, the log in the workstation is going to show a trusted domain from AWS. Most of threat intelligence tools tends to bypass trusted domains. So Microsoft, Azure. So I'm going to be able to execute API calls from a trusted source to a trusted destination. So that would hide my source IP and also would hide the request I'm executing to. The thing with this is also part of the development lifecycle. This is the architecture diagram that I'm going to replicate. As you can see here, we have like the non-authenticated user, so I don't need permissions to execute the API calls against my backdoor. I'm going to execute API calls against the API gateway. This will trigger my code running in a Lambda function. I need to give the Lambda functions permissions to execute what I'm going to execute. The Lambda function is going to be pulled from an ECR repo. So the thing that I need to do is like from an authenticated user, being able to build this infrastructure with Terraform or whatever. If I build it manually, I would be able to execute much less API calls. Everything that we do in an automated way is going to generate noise. If I execute this with the AWS CLI, I can execute the specific API call that I need, and that's going to lower my fingerprint. So I tested it, created with Terraform, and it was not detected. But at the same time, we depend on what is the detection mechanism that the defender have, and we're going to see a little bit how to identify that and how to reduce and dampen their defenses to understand better what we can do and if we can execute this. This is the meter TTP that we are going to execute. We are going to use a valid account to execute a serverless execution to implant an internal Docker image. The thing is that I'm using a backdoor because it's the most noisy thing that we can do. This should be like detected because I'm like controlling an AWS tenant from outside the organization and it's not detected. But you can use that to execute whatever post-exploitation tool that you would need as a red team exercise. Are we okay? So what we need to evade? First of all, there is VPC flow logs. This is the net flow log that would be like monitoring everything that working in the network level of the AWS environment. But we don't care about this because, as I told you, the shared responsibility model is above that. So this is AWS responsibility. There is no VPC flow logs for what we are going to do. So if the defender has VPC flow logs enabled, they are not going to detect, they are not going to get the trace of what we are doing here. There is API gateway logs, but API gateway logs is going to log the queries against the API gateway. But as we are creating the API gateway, we have the control on if this is enabled or not. We need to check that this is not enabled, and if it's enabled, to disable it, or at least to do the same techniques that I will show you to disable other types of log to make this not happening, right? This is the important one, CloudTrail and event history. CloudTrail is the log that is going to record every API call. Everything that we do, from creating a user, creating the API gateway, the lambda, everything is going to be recorded in CloudTrail. Yes? There are two types of ways of getting CloudTrail logs. The most important one is the event history. Event history is always enabled and cannot be disabled. It's something that's going to be always in every AWS account. And the thing with CloudTrail is that of event history is that it's going to record up to 3 months of log. So if I execute something now, I cannot disable that. I cannot remove access to that. And it's going to be recorded for 3 months. The CloudTrail alternative is the most strategical way to implement this. The defender needs to enable CloudTrail. To get them, it's going to be shipped to an S3 bucket, and they can get whatever amount of logs they want with CloudTrail. The issue with CloudTrail is that it has like 15 minutes of delay from when an API call is executed and when it's recorded in the S3 bucket. So the issue with that is like I have like those 15 minutes of time plus whatever it needs to be ingested in the SIEM and whatever is needed to trigger an alert. So I start to create like a buffer of time that I have to execute whatever I want to execute. The CloudTrail integration is the most common for CM integrations and then for the incident response. When we see logs in AWS, it's mostly the second case. And we have those 15 minutes to do what we want. Because if I have those 15 minutes to disable the log being generated in CloudTrail, I can implement the infrastructure and then I can re-enable the CloudTrail logs. They are going to see a small gap of time on what they are not being getting logs. The thing with CloudTrail is when they are shipping those informations to the CM, they have different layers because in AWS you have different tenants that are different accounts, and each account has different regions. So I can disable one region, not all of them, and with that they are going to keep getting logs, so they are not going to get the alert that they are not getting logs because they are going to get logs from different sources. I can work in the region that I disable, and then when I re-enable the logs, they are not see the difference, especially if they are not monitoring the tampering of those kinds of information. The thing with event history is I cannot do that, but I can work with if they are shipping the event history logs to the CM, the event history are sent using a CloudWatch rule that I'm going to show you in a sec. So I can work with the CloudWatch rule that is shipping the logs. I cannot work with the event history on itself. So no matter I do, this is going to be recorded. The thing is that the event history API is like really difficult to work with because it has like a really low rate limiting and the export feature is like awful. So for a defender working with event history in multiple accounts and multiple regions is like a mess. So we can that's why everybody like trusts CloudTrail, but everybody both of them has their drawbacks and both of them have the strongest points. And the most difficult thing that we need to bypass is GuardDuty, that is the threat detection tool I told you. So whatever I'm doing with against AWS, it's going to be recording GuardDuty, and if it's bad, it's going to trigger an alert. For example, I can show you my GuardDuty findings. Here I have like the GuardDuty. This is the GuardDuty. I don't know if you see it well because of the light, but this is these are the findings that have been generated these days regarding what I was doing for testing and stuff. What I did was to generate an integration that's going to, whenever I trigger an event, I can execute a command to force an event, and this is going to generate a new finding. And whenever this finding is generated, I need to change region. I'm generating a sample finding. As you can see here, this is a sample finding I have just generated with a severity high. And whenever this trigger is going to, after the integration happens, we're going to monitor this because it should notify me on Discord, right? So I have the security detection enabled with the full integration for me to get a notification with Discord. The thing with GuardDuty is like the time in between the interactions with API calls in AWS, it's always set on pooling. So it can wait for 5 minutes, 10 minutes, 15 minutes, based on every part of the integration to work. So if I try to disable GuardDuty, that's something that most SIEMs are going to detect. But I can work with the integration for GuardDuty to ship the event to the incident response team, and that's not something that is usually monitored. So the integration, in the meanwhile, that we are seeing the event to be getting here, that it last time I present this, the event arrived after the talk, like 2 hours, while we were having like some coffee. But the integration is easy, but basically I have a CloudWatch rule that's going to work like this. It has like an event pattern. This is my CloudWatch rule, and the CloudWatch rule, as you can see, it says GuardDuty finding, right? This, whenever the event bus sees this, is going to trigger that to a destination. And the target is like this GuardDuty Discord integration lambda. The GuardDuty Discord integration lambda, what it does, as this is the IDA I told you, is like, this is how you should see a lambda function working if you are not using a Docker image. You can see the source code of what the integration does. This lambda function, what it does is like get the JSON event from the GuardDuty trigger, parse it, and publish that to Discord, right? The thing is that if I'm as an attacker, understand how the integration works, so I have GuardDuty, I have the CloudWatch rule, and I have the lambda function. And I know that the defender is using this integration to get notified. It can be Discord, it can be PagerDuty, OpsGenie, whatever. I have different things to do. For example, I could try to get the code and to understand what are they doing to notify. In this case, it's Discord, because I have this wording here that says Discord URL, right? And I'm getting that is getting the Discord URL from the environment variables. So I could check in the configuration, the environment variables, and I can see a Discord webhook, right? This is a common integration that is normal to be seen. If I change a letter in the Discord, in the webhook, the notification is not going to arrive, and the lambda is not going to fail. So I don't need to execute the API call that is the activate detector of GuardDuty. I can update the lambda function that is also an API call that is common in the software development lifecycle, and that API call is like not as dangerous for a detection perspective than deactivating the GuardDuty. So even though the GuardDuty is going to detect me, they are not going to get the notification. Besides that, GuardDuty is not going to detect me. I don't know if other things I can do is like I can change the event pattern to reflect what I want, right? If I change this event pattern, the API call is going to be update CloudWatch rule, and most CMs are not detecting those kind of changes. And if they are going to get a lot of false positive because these kind of events are used to monitor every alarm in every part of the software development lifecycle. So it's going to trigger a lot of false positive if they create a rule on this and it's not fine-tuned. Other things that can detect me is like CloudTrail itself, right? If I go to CloudTrail, I would see that we have different choose stuff, like the CloudTrail that's shipping logs to S3. So the logs are going to be shipped in an S3 bucket. So if they are integrating this to the SIEM, they're going to see this in a formatted way. If they are not, and they only have this enabled, they're going to see this pattern that is awful for analysts. So you have year, month, day, and a lot of JSON files in this. So if you're an analyst and you get this, you're going to struggle a lot because you need to download all the folders and start parsing that. And this is a lot of data to analyze. The thing with this is like the S3 bucket is like any other storage, and the S3 bucket has a policy for me to understand if I can ship logs to the bucket itself. So for example, if I go to the S3 bucket again, we are going to see that it's in permissions, it has a bucket policy. And I made a change in here that says in the principal is the one that says who can publish information in the bucket. So the principal says GuardDuty when it should say CloudTrail. So that API call is to update the bucket policy of this bucket. And as I'm generating the API call to the S3 bucket, the S3 bucket is not going to accept logs anymore. That's a dangerous API call. But as it's not accepting logs anymore, the SIEM is not getting that API call and the alert is not going to trigger, right? And also, if it triggers, when they are trying to debug the, the issue, it's super hard for an analyst to understand what to look in the policy because it's something that is the most difficult thing for us to understand what's going on with the policy. And also, if I change the principal by a principal that is allowed, like GuardDuty instead of CloudTrail, and you are like in the middle of an incident and you're looking for CloudTrail and you say GuardDuty, it's almost the same because it's also a security tool. So it's easier for the analyst to get confused, right? I have other ways to hide myself, but let's move to the last part of the demo. So the thing is that what I'm going to do is to generate this Docker file. This Docker file is this Docker file. What allows me is to generate a lambda function with an AWS CLI. So it's not malicious code, it's something that is common. I'm installing AWS CLI inside the Docker file. I'm running this code that what's going to do is like it's going to parse whatever I execute in the post request to the command part of the Docker file, and I'm going to run in the architectural diagram that I show you. So in a lambda function from an ECR and using the API gateway. If I show you here the API gateway, we can see it. This is the endpoint that I'm going to execute. And as you can see here, I'm executing things. The API is in Virginia. But I'm using Virginia because it's the default region, and also because I have all my monitoring tool enabled in Virginia. If I go to the GuardDuty integration, you're going to see that everything is enabled for detection. Yeah, we have this lambda protection tool fully enabled. We are in South America again. Lambda protection tool fully enabled. So the thing with this is like, whenever we try to execute API calls using Postman, again, the endpoint, for example, I can use this this is, for example, an STS get core identity. This is the URL for the API gateway, and this is the endpoint of the API. And I'm passing the command that is AWS STS get core identity. STS get core identity is like a who am I for AWS. Here you can see that is like user ID malware test. This is the ARN of the role that is being used by the lambda function that I'm executing API calls against. The thing with this is like this is an assumed role, and the malware test name is the name that I gave to the session that I'm executing. So I'm going to show you logs from the malware test session, but the malware test itself, the malware test role doesn't exist. The real name of the role is malware test role. So whenever you are doing the investigation, everything is going to be logged as malware test or the name that you want to give them. And if you use a different name than the role name, it's really difficult to match the origins of that. For example, what other things that we can do, for example, is like we can execute an LS on S3 buckets, right? This will allow me to see every storage bucket in the AWS account. The thing with the S3 endpoint is like this is a regional endpoint, but at the same time, the S3 buckets are global. So if I execute this command, as you can see here, there's all my S3 buckets. If you execute this against the default region, this is going to be logged in Virginia. But I can execute the same in Oregon, for example, instead of executing this in Virginia. And what this is going to do is going to retrieve me the same information, but the log is going to be recorded in a different region. Another misconfiguration that defenders do is like they enable all the detection in the regions that they are going to use and not in the regions that they are not going to use. So this API call is going to be logged in in Ohio, and the GuardDuty is enabled in Virginia. So I can get some enumeration and retrieve some information from a different region being logged in a different location and also working in a non-monitored location. Other thing that we can do to cover up a lot more our infrastructure is like jumping from different roles. I can use this command that is called assume role to assume a different role in a different account. So I can use this lambda running in one AWS account of my compromised tenant to jump to another account, and the only log that is going to be recorded in the AWS account is the assumed role, and everything else is going to be executed in a different region. As we can see here, we are going to get a lot of credentials that we can use for the role to be used. As you can see here, we have like the access key, the secret access key of a different account. If you here, it's really small, but the account number is 59. It starts with 59, and if we go to the get core identity, this account starts with 94. So this I'm jumping from one account for the other from using this lambda execution. The most interesting part is like GuardDuty haven't detected me, I hope. The last finding is still the sample that I generated, the high one that I show you. But also, if I go to CloudTrail, and this is the most important part, I think, for the detection, and I go to event history, I'm going to see a lot of things, right? This is how event history looks. As you can see here, there is the malware test API call that I was executing. Again, you need in order to investigate this, you need to know that the malware test user is the dangerous one. If I go to the IAM, the role I'm using, again, there is no malware test user. So if you see an API call coming from a user and the user is not in the user list, it's weird, but you need to see that first. And if I go to the role, the role is malware test with some shibris after that. There is no malware test role because that's the session that I set to the role when I'm assuming that. The other thing is that if I filter by event name and username malware test, we're going to see all the tests. For example, if I go to the assume role and we start to analyze what's going on, this is how a CloudTrail log looks like. I have this IP. This is the IP that's being recorded in the CloudTrail logs, right? But if I go to see what's my IP, this is the IP I have in my computer. So besides I'm executing API calls from a Zagreb IP, the IP that's it's being recorded in the CloudTrail log is different. And if I do an analysis of the source IP, I'm going to see that the origin of this IP is an Amazon Data Service. So besides I'm executing the API calls from my computer, the registry, it's going to be registered for an Amazon server from Virginia. Another interesting thing that I can show you here is what happened if I change to Ohio. And in Ohio, I'm going to see much different logs. It's not recorded yet. So the API call that I executed in the S3 bucket in Ohio is not yet recorded. I haven't got here. It arrived the sample finding that I executed first. So we did all this thing and yet we got the sample finding. So if I had like almost like 10 minutes to do whatever I want. In the meanwhile, that the GuardDuty generated sample finding arrived to the notification server. So we need to work with this kind of space and time modifications, like the 15 minutes with CloudTrail, the 10 minutes with event history, the region trick with whatever is going to be recorded or not, and using AWS services in normal development lifecycle to bypass what the GuardDuty understand that is something bad. So if I can execute the API call within the lambda, within my malware, with a noisy thing as a backdoor, imagine if you do something like more silent, like trying to execute an info stealer or getting persistence or whatever you want. The thing with and the difficult thing with this kind of thing is like if I am assuming a role in another account, I have compromised an account with this technique, and I'm assuming a role in another account, the assumed role is also going to come from an AWS IP. So the second compromised account is also going to get this kind of stealthy behavior where the API calls are coming from. The most common thing that we do as incident responders is to try to hard push the source IPs, try to understand if something coming from a weird location. And with this, anything is going to come from a weird location. Well, I have some security guidelines to show you as last thing. This is important thing that we should do as defenders to stop this from happening. We need to block whatever we are not using, regions, AWS services. If you are not using Lambda, you shouldn't be able to trigger a Lambda in your AWS account. Less privilege on AAM is the most important thing, because if I got access like this, you're not going to be able to detect me, not because you are not doing your job, because AWS is not providing you with the tools for you to do that. Monitoring, try to enforce monitoring on those resources that you know that are part of your critical infrastructure. So you have your Lambda function is used to notify when something is happening with GuardDuty. Create detection rules from that Lambda 2, from that CloudWatch rule 2. And yeah, I think I'm out of time. So that would be it. I don't know if you have any questions or something.
Maybe some comments. Never go to CloudTrail on-prem.
It's cheaper. No, the advantage with Lambda function is like it can be really cheap if you are like doing something small. So if you need to handle a big server to POC, to do a POC on a development, is like super hard. But it can give you these big holes, right? And also there are a lot of info stealers trying to get your credentials from wherever you are. So it's like it's important to be safe with IAM.
So if you think about any question, you can catch up with Santi after, and thank you for your presentation.
No, thank you for listening.